For the last couple of videos, I've been talking about white balance, and specifically the capabilities and settings on Canon's EOS R5 and R5C. And throughout that process, I have been promising that I was going to do a video talking about how to set custom white balances on those cameras. What I realized in the process of getting ready to do the video on custom white balances is that for the vast majority of us, setting custom white balances does mean using some kind of white reference target. And it would make a lot of sense to talk about what worked really well for a white reference target and the options that you have available when going into talking about setting custom white balances. So when it comes to setting white balances or white balance targets, there are two approaches that you can use for this. One is an incident approach and the other is a reflective approach. Incident approaches are, well, one, color meters, so professional color meter measurement tools that you just put in front of the light and it tells you all of the things you need to know about that light. Your other option are white balance lens caps, or something that goes over the lens to provide a diffuse white reference with the light that the image is being shot in. Now, reflective measurements simply are going to use a white balance reference target of some form. So let's talk a little bit about what these are, what is available, and how well all of this performs. And speaking of how well all of this performs, I did a bunch of testing here because I was interested to see how the commercial stuff stacked up, how some DIY options stacked up, how the whole situation played out in general. So I did 3 tests. 2 under LED light, one at 3200 Kelvin and one at 5600 Kelvin, and one out in the daylight under natural sun where there's a high component of obviously UV involved. For the LED light, I used an Aperture Amaran P60C, which is an RGB WW panel, and Aperture's color science on their RGB panels are pretty good, so it pretty accurately matches what you would necessarily expect. The process I used was to set a custom color balance using the live method on the EOS R5, and then photograph the target with that custom color balance so that I could look at what the option or what the camera came up with in the post-process system. So, incident approaches. Basically, what it boils down to is you need to put your camera or your meter in the light that your subject will be measured under and measure that light. So basically the same approach as if you were using an incident light meter, only you can potentially use your camera in this case. Now, there are a lot of situations where this works fine, and there's a lot of situations where this is not overly practical. For example, in a landscape, if the mountains that you're photographing are being lit by direct sunlight and you're under a cloud, well, it's really hard to get a correct meter or correct white balance reading that way. So, as I said, there's basically 2 approaches to using this. You can use a color meter, or you can use a white balance lens cover. So color meters are probably going to be your most accurate option out there, though, and most flexible in many respects, though they are going to be probably the most expensive option available. Color meter like the Sekonic C800U is about $1,700, $1,600 to $1,700 new. And while they provide a ton of information and a ton of flexibility, you can use them not just to set your camera's white balance, but to measure the performance of lights and to measure the measure and match lighting settings. That is a lot of money for a very specific tool. On the other hand, lens covers are much cheaper if you want to buy a commercial one, and however, they are a bit more restricted in the sense that they're only really going to be good for setting custom white balances. That said, if you are shooting with a Nikon mirrorless or potentially even their DSLRs or a Canon cinema camera, these cameras, and there may be some others out there as well, these cameras will provide the color temperature and correction that they set or they measured for the custom white balance. So you can use that to set other cameras without having to do the custom procedure on all of your cameras. But again, this is going to be pretty clunky. Now, there are some hacks for these solutions, specifically for color meter. You can use a monitor-style colorimeter profiling device or even spectrophotometer, and in conjunction with some open source color management software called Argyle CMS, and specifically the tool that it provides called Spot Read. So if you're interested in doing this, the command you need to run is spotread -a -cap O, and that will take a single measurement using the ambient light measuring capability of your colorimeter. So I'm using here a i1 display. It's an older model from X-Rite, but most of the modern stuff from Spider or Calbright will do these kinds of operations. Put simply, you point it towards the source, you run the command on the laptop, it will give you a color temperature and a delta UV error. So delta UV is the green magenta error. Now there's some limitations to doing this. It's really clunky. You do need to have a laptop or potentially an Android phone running the Argyle Colorimeter Pro software on it, and a supported color meter for that. In addition, you need to be in a relatively controlled environment. So the light from the sun is going to be too bright for the vast majority of these color meters. It's going to overwhelm them, and they're not going to be able to function properly or give you an accurate reading. So this is something you could potentially do in a studio where you shoot tethered to get more accurate information, but by and large, this isn't going to be a great option. That said, I went about this process because I needed a color reference for the rest of my tests, or a measured reference for the rest of my tests. So this is going to be these are the reference values that I ended up with. For the P60C at 3200 Kelvin, my colorimeter measured 3229 Kelvin, so pretty good there. For the P60C at 5600 Kelvin, my measured 5757 Kelvin with the colorimeter. Not quite as good as where it was at 3200 Kelvin, but pretty reasonable. Now, I did try measuring the sun outside with this. It did not work at all. I got a wild range of options, and even making a average of the different measurements that I had didn't come up with anything remotely approaching the realistic color temperature that it should have been. So I was working at about 10:30 in the morning on a clear day with no clouds in the sky, at least no clouds in the sky overhead. And the color meter came up with an average of like 7,600 Kelvin, almost 7,700 Kelvin, which is definitely not right in those conditions. So what I ended up doing as a reference for the sunlight tests is I just took the median value of all of the different test subjects I used. That ended up being 5,750 Kelvin, just as a reference. Now, hacking around the photographic white balance lens caps, basically the solution that you have available to you is to use diffusion of some sort. I tested two possible options. One was a piece of Lee Zircon 810 diffusion. This is their strongest Zircon series LED diffusion. It's really tough, high quality stuff. It would probably be what I would want to carry if it performed better. And the other test I tried was just straight vellum paper from a pack of paper that I bought at like Office Depot for drafting and that kind of thing. So the performance here, the Zircon diffusion, which I expected to be much closer to neutral, turned out to have an average color error of about 16 myreds from the actual measured values. And the vellum paper, which I didn't expect to perform very well at all, ended up having an average color error of about 7 myred from the measured values. So actually, the vellum turned out to work pretty well, and of course, it is pretty cheap. Now, I don't typically use incident approaches. It's not my primary approach. In fact, it's not an approach I've ever used aside from the testing that I did in this video. So that brings us to reflective approaches, measuring or setting white balances using reflective techniques. Of course, this is a white target like the one over here, set up in the light that you're going to shoot in, and you use that as your reference. Now, the question is, what makes a good white balance card? And the answer is it has to really satisfy 3 criteria. First of all, it needs to be white, or very nearly so very light gray. This is twofold. First of all, the brighter the card is without clipping, the higher the signal-to-noise ratio you get from it, and the better the camera can calculate the actual white balance, so you get better performance out of this. The second consideration in this respect is with respect to gray cards, so something to keep in mind, photographic gray cards are intended for setting an exposure level. Their requirement is that they reflect 18% of the light that's incident on them, not that they reflect 18% of the light perfectly neutrally. So a photographic gray card can have a color cast to it that would not be ideal or good for white balancing and still be perfectly acceptable as a exposure reference. Now, the second criteria is that the card needs to have a matte surface. Specular reflections will cause clipping, and clipping breaks the ability for the camera to measure or set a custom white balance. So any surface that's shiny or reflective, that's going to be a problem. You really do need something that is matte. Finally, we want something that's not just spectrally neutral, so reflects all color wavelengths equally, but we want something that doesn't necessarily change color under different lighting conditions. So this is a problem that you run into with paper, specifically papers that have optical brightening agents in it, and we'll talk about that in a second. When it comes to all of these options, what do you choose? Well, obviously, there are commercial targets out there. In fact, I own a handful. I own a Calibrite white balance target. It's this one right over here. It's an 8x10 target. It's purpose-built for white balance operations. Also, I own an X-Rite Pocket X-Rite Color Checker Passport. It's one of their little portable color check cards. That also has a white balance target in it. Again, purpose-built for measuring white balance in your, setting white balances in your scene. I also have some Vortex Media warm cards. Primarily, these are targeted at making calibrated adjustments to the white balance that you are shooting. However, they do have neutral cards in there so that you can make accurate white balance measurements. And these are just the start. There is a whole lot of other commercial targets out there. That said, with 4 commercial targets available at my disposal, I wanted to see how things performed. So testing the Calibrite white card, I got an average of error of 5.8 myriads compared to the measured references that I had, which is pretty good. Using my 8-year-old X-Rite Color Checker Passport, the error went up to 10.2. So there is some validity in the comments that you should replace your color cards, your white references, and your color references with some regularity. Now this, of course, could have been simply measurement error to some extent. My cards kept in the dark in a humidity controlled environment. It doesn't appear to have discolored or shifted, but again, it is 8 years old and probably doesn't perform as well as it did when it was new. I also tested in the Vortex Media warm card set. There is a white matte card and a white or a gray matte. Tested both of these. The white card turned in a performance of 9.4, so a bit better than the Color Checker's Passport's white target, but not as good as the new white card. And the gray target turned in a pretty disappointing 12.0 myrad error. Again, illustrating that gray cards not necessarily intended to give you a neutral image, they're intended to give you a proper exposure. Now, DIY options for reflective targets are obviously many. A lot of people will use copy paper or white paper, something like that, and that seems to work for some people, although I would caution against it if you're really concerned. I also tested a couple plastics, so PTFE goes by the trade name Teflon, or is better known as Teflon, and white polystyrene. So a note, if you are using printer paper or copy paper, do check the paper for optical brightening agents. As I said, these are not good if you're working outside. If you're working inside under LED lights, that copy paper will probably be just fine. Optical brightening agents work by converting incident UV light and then re-emitting that as blue light. So it takes basically light that you can't see and converts it back to light that you can see, which makes the paper brighter. It also makes the paper bluer, which makes it look whiter in many circumstances, and that's pretty much what the objective is there. Now, if you don't have any UV in the environment that you're working in, then optical brightened paper will be fine. However, if you are working in a UV lit environment, it will throw off the white balance, and we'll actually see this in the testing. Now, for plastics, I started with PTFE or Teflon, largely due to an article published by Fast Raw Viewer. So those are the people behind the software Raw Analyze, Fast Raw Viewer, the 5D or the Canon Dual Pixel Dynamic Range Extender, and the open source raw conversion library LibRaw. So they do have a good idea of what they're doing when it comes to processing image data. And they did a series of tests on white balance targets and found that PTFE, specifically, they tested the white thread tape that you use for plumbing, worked really well. Under their spectrometer, it had a very flat spectral response, including, or in some respects, better than even commercial white balance reference targets. It's certainly relatively inexpensive. The plumbing tape they used is dirt cheap. I bought a sheet of PTFE, and even that was under $30 and big enough for me really to get 2 targets out of. The sheet I bought, I found to be pretty robust, and what's nice is it's semi-flexible. So I got a 16th inch thick piece of material. It was 12 by 6 inches or 30 by 15 centimeters, and my piece cost me about $30. It does need a little surface prep, some sanding to make it perfectly matte on the finish, but otherwise pretty solid. Since I was thinking about plastics, I also tested the only other plastic I had readily available, which is white polystyrene or white styrene sheet. So this is the stuff that you use for building scale or miniature models. I had some left over from years and years ago when I was doing a lot of that. And this stuff is even cheaper than PTFE. You can get pieces for as little as $5 for like a 6 by 12 inch or 15 by 30 centimeter sheet. And based on the testing, it performed surprisingly well. Now, one of the limitations of styrene is it can yellow with age. In fact, it can also be a slightly yellow out of the box. So you do have to be careful with that. But I basically looked through the scraps that I had in my drawer, found one that looked really white, or not yellow, I should say, and went with it. And this is the results that I came up with. The PTFE performed incredibly well, averaging an error of color, or a color temperature error of around 4.5 myrad, which is really pretty good. The styrene blew my socks off and did phenomenally well, averaging only a 1.9 myrad color temperature error, which is staggeringly good, especially given how inexpensive the stuff is. Now, copy paper and bright white copy paper averaged 9 and 9.8 myrad errors, but if you notice, under daylight conditions, the error goes through the roof due to the ultraviolet that is being converted by the optical brightening agents. Now, I thought the copy paper I had wasn't ultra bright. It probably wasn't, but it did still have optical brightening agents. That's going to be a concern you're going to run into with copy paper or printer paper, kind of across the board. So, conclusions. What do we take away from all of this? Well, the best DIY materials I found for white reference cards, and in fact doing white balancing as a whole, was PTFE and styrene. And I was very surprised at how well styrene did in comparison to PTFE, and how both of them did in comparison to commercial cards, although I kind of expected PTFE to do pretty well. Styrene, though, is dirt cheap, so even with the limitations of it potentially yellowing with age or exposure to light, given the costs, you can literally throw the stuff away, and it would take years to basically run into the same costs as a commercial white balance target or even a sheet of PTFE. And again, remember, those commercial white balance targets, after prolonged exposure to light, are not guaranteed to be white or accurately calibrated anymore. So the styrene I used came from Evergreen Scale Models. The sheets I used were from their 940 series package, or 940 series sheet. It was a 6 by 12 inch or 15 by 30 centimeter sheet, 40 thousandths of an inch thick or 1 millimeter thick. And you get 2 sheets in a pack. They cost $4.85. So dirt cheap. If you need something more robust, the 9100 series or 9100 pack is, again, a 6x12 inch sheet. It's 100,000th of an inch thick, or 2.5 millimeters, and you get one sheet in the bag for $6.49. So if you cut them in half, make 6x6 targets, you're talking a lot of targets for not a lot of money. And given the performance I saw, you should expect pretty good results. So with that said, what method should you focus on or consider? Do you want to go incident? Do you want to go reflective? Which way is best? Well, I can only answer this from my personal experience. In more than 10 years of photography and about 4 years now of doing videography, I've never actually used an incident white balance solution. I have used colorimeters, obviously, on my monitors, but not for setting white balance on my camera. I have, in the last 4 years, since I started doing video, due to the much less, more limited sort of adjustability or post-processing capability that exists in compressed video, have started using white balance targets, but I use reflective solutions because I find them easier to deal with. And by and large, I find it easier, especially when I have a camera set up and everything, to stick a white balance target on a stand, put it in the light that I need, or have somebody hold it and shoot my reference from that, as opposed to trying to disassemble a camera rig and put a lens cover on and all of that kind of stuff. Preferences for me, I like white balance targets. I do use commercial targets. Specifically, I use that color checker from Calibrite. I found that I needed a bigger target, which is why I'm using that. Even then, that is not overly expensive. I think it was about $60 or $70, which compared to everything else that we have to deal with in cinematography and photography is completely reasonable. However, if you are doing stuff more on the run, I would really just recommend something like a color checker passport. They're a little bit more expensive than a simple white balance target. They're certainly a lot more expensive than carrying a piece of PTFE in your bag. But they also have the color check cards, so if you really care about getting super accurate color in any kind of situation and environment, you can always shoot the reference of your color check passport with the color references and then use that to do custom corrections for color across the board for the light. The dream of mine, at least, and I think this is sort of the aspirational goal, is to actually have a color meter. A Sekonic C800U is what I consider to be the most reasonable. This is certainly what you would want to have if you're doing any kind of lighting in production on small films, TV, any kind of serious production, simply because of the speed it allows you to work at setting up lights, getting the white light color temperature information, and making sure that you can test and validate what lights you're using and how everything balances out. So, with that said, I'm going to wrap this up here. I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. Finally, if you'd like to help support this channel and future content like this, please consider hitting that thanks button if you can. Every little bit does help. And as always, thanks for watching, and I'll see you next time.